Okay, welcome everybody to Flat Earth Civil Discourse episode 19. My guest is joining by audio. His name is Kimo. Kimo, please say hello to everybody and introduce yourself. Welcome to the conversation.
Hello, everyone. Thanks for having me here, Charles.
Oh, it's a real pleasure. And I was just telling him backstage that we actually had an email back and forth. It was June of 2019, and we just never got the chance to have a conversation. So this will be our first opportunity to talk, and we're just gonna have a conversation. And just for the audience, I set these things up as civil discourse, not it's not a debate. I'm not trying to demolish Chemo with my arguments, and presumably he's not going to demolish me with his. We'll talk about some ideas. We'll disagree on a lot of stuff. We'll agree on some stuff, and we'll just take it from there in a very civil fashion. So I do appreciate everybody's attendance. So Chemo, what's on your mind?
I think that we've been told information about the shape of the Earth and where we live, with nothing really, in my opinion, that is, to support it. Every image that we have, obviously, is CGI. It's a composite, and that's how I got into the flat Earth in the first place, because I was looking at different conspiracies, and I came across this flat Earth conspiracy, and I ignored it for 2 weeks. I say that there was a guy's channel. I was looking at his conspiracies, and then he put flat Earth. This is like 7 years ago now. He put flat Earth on his channel,
Okay.
and I saw it, and I completely ignored it. I thought, well, this is crazy. This can't be right. And then he uploaded other different videos, and I even remember messaging him saying, "Hey, can you take down that flat Earth video because it looks like it's discrediting the truth?" And he messaged me back, and he said, "Well, how do you know that you're on a globe?" And I was like, "Well, that's obvious. The sun is round, the moon is round, everything is round, planets are round. Why wouldn't the Earth be round?" And he was like, "Okay, so if you can show me a real picture of the Earth, then we can obviously talk about that." I said, "Yeah, fine. Give me 2 minutes. I'll definitely have to show you that." And I'm still looking 7 years later for
Okay.
that real picture. So yeah, he kind of introduced me to the idea that it's either a painting or a composite, and I just went from there really. And then
Okay.
obviously, yeah.
Yeah, and there's a lot of interesting argument for the whole CGI and different aspects about like whether when they release like the blue marble, and then people look into it and they're like, oh, but it's just a composite, and it's like, yeah, it is a composite. And so then of course that opens up the door to the conspiracy, because here they are admitting that particular blue marble image was a composite.
Hmm.
Now, my argument, for flat earthers is never to appeal to like say photographic evidence collected by somebody else. So, of course, the globe side, you've heard of the Himawari 8. You've heard of all of the Hasselblad images taken, the high res black and white images taken by the Apollo crew. Like none of that's gonna sway you, right?
Right, right.
So I don't go there. Oh, what were you gonna say?
No, I was saying right. I'm agreeing with you. Yeah, right,
Yeah, yeah,
right.
yeah. So I don't, like people on my side are like, oh, there's just so much photographic evidence, and it's like, okay, but if someone's coming from the place where the photographic evidence is fake, then more photographic evidence isn't going to sway you, right? So, so I always tell people that there's a couple ways of figuring out the shape of the Earth. One is to look down, and the other one is to look up. And if you look down, it looks really flat. you know, it's really really tough to perceive Earth curvature here on the
Hmm.
ground.
Hmm.
But if you look up, and the sky is free, you don't need any equipment. But a lot of people are like, oh well, you can't tell the shape of the floor by the shape of the ceiling, and yeah, the sky's a dome. The sky's a dome for everybody. All right, so that's not what I'm going for. So have you looked at any of the experiments that are on my channel, Chemo?
I can't say I have. No. What experiments have you got?
So basically, every single one is talking about very carefully looking at the sky and then presenting. And I don't know if you're a model guy. Like, there's some flat earthers who are like, I don't subscribe to any model. I just know it's not a globe. And that's an interesting, that's an interesting approach. There are other people who are like,
I don't subscribe to any models, but there is a flat Earth model. I don't know if you've heard of Walter Bislin.
yes.
So he's got this flat Earth model, which kind of explains things for globe earthers, how things work on a flat Earth. So it kind of explains eclipses, equinox, day and night, things like that.
Yeah,
Now, obviously, in that model, there are things where the globers would say, well, you have to account for extreme light bending and things like this. And, my response to that is, well, with any kind of model, there has to be something extra in it that you have to account for. So in the heliocentric model or the globe model, you have what we call gravity. Okay. So without kind of gravity, the whole model falls apart, doesn't work. So right. I guess you could say the same thing with this flat Earth model. If you don't account for or don't allow to account for the light bending, then obviously that's not going to work either. So in both cases, when it comes to models for the flat Earth and the globe Earth, you've got to accept something which I feel cannot be demonstrated with an experiment.
Okay. Would you agree though that when globe earthers appeal to gravity, that the gravity equation is, it couldn't be simpler. It's got, 3 variables in it, and it's just a couple terms. You can write it on a postage stamp. It's such a simple formula. And globe earthers claim, such as myself, that that formula applies to the Earth, Moon, Sun, the planets of Jupiter, the solar system. Like with this one simple formula, you could use to make predictions. You can do all kinds of stuff with just that one little formula. Whereas when you're saying, with Walter Bislin's model, and he's a globe earther.
He's right? A glober, yeah.
Right. So with his model, and I think somebody referred to it maybe as the personal atmospheric dome, where he kind of took a person someplace on Earth, and then he kind of put a dome, sort of wrapped a dome around that person, and then kind of showed where things would kind of line up. I'm not super familiar with Walter Bislin's flat Earth model, but the question that you just raised is extreme light bending, extreme light bending to, like if you say sunrise due east, and then in the actual model, well, sun is not actually due east; it's 30 degrees away,
right?
And also the fact that sun rises and sets, so you have some sort of extreme light bending. Then there's no equation, there's no predictability, there's no. Do you see what I'm saying? Versus gravity, which is like a real simple equation,
Well, like I say, it's you either accept one or the other or dismiss both. And in the case of gravity, as far as I'm aware, you have an equation for gravity. But when it comes to the real world, there isn't anything really practical, demonstrable, repeatable when it comes to proving that gravity is a force. And we know that Einstein superseded Newton, so we know that it's now the bending of space-time.
Right.
So, of course, we don't have an experiment to prove the bending of space-time. So, like I say, for me, there are models, but you have to kind of accept something extreme, either, like I say, gravity being a force, which we now know it's not, or you have to accept the light bending, which is something, again, I'm not sure if people can demonstrate.
Yeah. Are you familiar with the Cavendish experiment?
Oh, absolutely. So, I don't know if you heard of blue marble science or something like that.
Yes, and Baryon just mentioned that in the chat, that blue marble science
built
the apparatus.
Absolutely. So, we challenged Blue on this. If it were to be an experiment, he would have to account for all the variables and manipulate that as the cause and effect.
Or keep them constant. Not necessarily manipulate them. You keep them constant.
Maybe so. But what happened is we had another user. He was called BioDuel, and I said to this user, this globe earther, okay, so have we ever seen Cavendish in a vacuum? And he went on to say yes, there are many papers on it. It's been done many times. He can contact university experts and he can confirm that. So he did try to do that. He tried to find a video of it. He tried to find a paper, but the paper wasn't supported with an experiment. He spoke to several professors, which never got back to him. So he decided to build it himself, buy the equipment, get it all done himself, and get ready. So, we waited around 6-7 months, maybe 8 months for this experiment, which he finally got around to doing. He live streamed it on Discord, and he didn't actually show the masses moving or attracting. What he did show was lasers, which was bouncing around, but he knocked it several times. He didn't set up the experiment with the conditions that we agreed to. Okay. I asked him live on the day, can you put the camera facing towards the masses, not next to it to give it another mass, but if you could zoom in, show us that the masses are actually moving. He refused to do that. So I said to him, look, we've never been able to see this action in a vacuum, because in a vacuum, the masses do not move. When we see Cavendish outside of the vacuum, we see the exponential movement. We see it moving, but there's a cause for that. And my cause...
Right. Okay, so let's call that a failure, okay? But why the insistence on the vacuum? I mean, the vacuum, yes, it can remove, pressure, but the pressure is the same on both sides of the weights. And you're keeping the weights, their masses are not changing. The pressure is not changing. So the weights should be able to move through air slowly.
Yeah, I mean, my focus was on why doesn't it move in a vacuum? And we've had kind of lots of answers as to why it moves outside the vacuum. But when it comes to a vacuum, my theory is that, you've got the temperature, you've got draft, you've got current, moving around, wafting around.
No, that's a very, very good point. In that the Cavendish apparatus and the apparatus that Blue Marble Science built, you have a cabinet that is holding the moving parts, so to speak. I mean, you've got these large masses that once you move the masses into position, you're those masses aren't swinging around, but the smaller masses which you want to swing, those are encased in a cabinet, and that cabinet is sealed so that air currents aren't going to disturb it, right? But anyway.
Go on.
No. The thing is, I do not want to talk about focus on gravity, because I think, you're a gravity skeptic, and obviously I'm a gravity believer, and I don't think either of us is going to get to any kind of resolution. And we're just talking to each other, so obviously we can't be performing the experiment.
No, I mean, I said to him, if you could show in the Cavendish, if you could show it in a vacuum, you would have the force. Yeah. You would have your experiment. So, if you or anyone, I'm willing to accept, observations and science. If anyone was able to show mass attracting mass in a vacuum, I would give up. Not pretty much flat Earth, but it would answer a lot of questions for the heliocentric model.
The argument that Globers would give is that when you take a rock and you drop it onto the ground, it's moving through a non-vacuum. So gravity works just fine in a non-vacuum. But I think what your point is like planetary. The planet Earth and planet.
Wait, hold on. When you say gravity, do you mean Newton or Einsteinian?
Well, Einstein simply created a more detailed model representation that Newton's gravity is a subset of Einsteinian principles. That so for example, go back and Copernicus said or first off, Ptolemy said that the Earth is a globe, everything revolves around it. Copernicus says the Earth is a globe, everything revolves around the sun with circular orbits or nearly circular orbits. And then Kepler came along and said the Earth is a globe, everything orbits the sun, but with elliptical orbits. So it's like in each case, the model just gets a little bit more precise. So we have Newton's gravity, and also Kepler's laws of planetary motion, and then Einstein comes along and just takes it one step further with different language, but Newtonian gravity is sort of a subset of Einsteinian principles. That's my That's my read on it.
So I mean, when we say kind of superseded, it's basically that Newton was wrong, because we have the motion of Mercury. It has a peculiar motion around the sun, and which is not
Do you know what's
affected by.
peculiar about it, though? That's the question. People cite Mercury all the time. Do you know what's peculiar about it?
It doesn't conform with the usual motions of a body around another body.
All right.
In so much so that they thought there was another large mass in space to account for this peculiar movement, basically pulling it out of its gravitational force.
Yeah,
They thought there was another force that was going to pull it, and they looked, they couldn't find. Then obviously Einstein came up with the theory of relativity, general relativity, things like that, and explained it with their gravity wells and things like that.
Yeah, Barry on nails it. Precision of the perihelia. So basically, Mercury orbits orbits the sun just fine. And I wanted to say thank you, Monkey Sage, for the super chat. I'm going to put that up in a moment. But precision of the perihelia. So Mercury is moving in an elliptical orbit, but that ellipse is precessing. And that was the quote unquote disturbing. I'm sorry for the rattling. My wife's doing laundry.
Oh, no, yeah, that's fine.
It's rattling the pipes.
That's fine.
So that was the disturbance, the precession of the perihelia,
which couldn't be explained with Newtonian gravity, by the way.
Which couldn't be explained solely through Newtonian gravity. Explained 99.9% of it. Okay.
Yeah, because everything seemed in order. It seemed that you have one larger mass, and you have another mass, and everything seems to be attracting, and so on and so forth. But like I say, there was like Mercury, which was not accounted for or explained by Newtonian gravity.
Right. But when you say wasn't explained, and it's really, really important, because oftentimes when we have a discussion between globe earthers and flat earthers, the level of, or the question of precision is kind of ignored, and somebody may say, well, there's an error, and then my question is, well, how big is the error? Is the error 10%, or is the error 0.1%? Because if the error is 0.1%, well, then maybe we were 99.9% correct, right? And so the thing about Mercury is that Newtonian physics explains 99.9% of what Mercury does. So you could say Newtonian physics is correct. If you take Einsteinian principles, that takes it to one more level of precision. Okay, but
yeah, I mean, I agree. Yeah, like you're saying. So before Einstein, Newton explained a lot of the motions. He explained how mass would attract mass and things of that nature.
Yeah.
But then, like I say, Einstein came up with a whole new idea and said that there is no acceleration, there is no force, and what we're looking at here is a gravity well, and things falling into that well.
Yeah.
So there's not, when we see things falling at the rate of 9.8 meters per second or squared, whatever you want to call it, that wasn't a result of a force. That wasn't a result of an acceleration. That was a result of objects falling into, like I say, into the gravity well. Now, obviously, that's just a theory. That's an idea which explains your model, but it's not something that we can demonstrate practically in the physical world. I mean, as we've just spoke about Cavendish, when you put Cavendish inside the vacuum, there is no movement whatsoever. We've never seen any movements. There are lots of papers written on this, but we're very strict when it comes to people peer reviewing papers without an actual observation or a practical demonstration.
So what would you say to us turning the conversation away from theoretical things where, you could have two PhDs who could argue Einsteinian principles, right? And I'm not a PhD in Einsteinian principles. And so it's like, we can kind of go back and forth and there would be nothing resolved. What would you say to returning back to Earth and talking about, what we can see here on Earth? Because, you've been in the flat Earth debate for a while, so have I. And the whole purpose of my channel, specifically the experiments on my channel, is to look up, to get people to look up and then and see what they can see when studying the sky. And you could argue, because of Walter Bison's model, that there's distortion, but I don't know if you saw my my most recent video was, can natural distortion, like through the layers of atmosphere, through the firmament, whatever, if the firmament exists, can natural distortion cause a perfect deception? Meaning what we see in the sky, yes, if we lived on a flat Earth, could this distortion cause what we see in the sky to perfectly 100% line up with the globe Earth model? That's really the point of my channel.
I mean, like I said, I'm not really, into modeling, because like I said, you have a choice of what to accept.
Okay.
So for me, in order for the model to work at any level, you would have to accept gravity, or you would have to accept light bending. So that's why a practical measurement, practical science, I think, is how we would go about understanding where we live. So, for example, if we're told water can conform around the exterior of an object, we would need obviously a practical demonstration of that. If we're told that there is a practical measurement of the radius of 3959 using Eratosthenes, which, by the way, assume the sun to be far away and the rays are parallel, again, which goes against observations with what we see in nature. That's the kind of thing that I would be looking for to be convinced that the Earth is what we've been told. You see. Now, I'm sure you've heard of the black swan.
Yes. I've had many conversations with Bo, who is the photographer, and I think he should get more credit. People talk about the black swan image, but they don't talk about who actually took those images. But yes, I'm very familiar, and I made a video on it called "Abusing Modus Tollens."
Okay, interesting. So what's your view on it then? How do you understand the argument?
So the argument, the black swan argument, or at least the modus tollens argument, if the Earth is a sphere with a certain radius, then the horizon should be a certain distance away. We see in this black swan image with the far, oil platform, we got Habitat in the front, we have Grace in the back, I believe, and then platform Grace is clearly in front of the horizon in that one image. Therefore, the Earth is not a globe.
At least it's not the globe that they told us. Yeah.
Yeah. So what I would say is, and that's why I named the video "Abusing Modus Tollens," is that the formulation is too simple. If the Earth is a globe with a certain radius, and I would say, and has no atmosphere, in a vacuum, a perfectly geometrically pure sphere, and it's like, then the horizon's going to be at a certain distance, and anything beyond that distance will be obstructed by it. So if we see something beyond that theoretical horizon limit, well, then maybe the Earth isn't a featureless sphere in a vacuum, right? With no atmosphere.
My position is that you can include, all the refraction, all the light bending, all the atmosphere that you need. It still wouldn't change the geometric points, the geometric position. So if you're a 1 foot observer, your horizon would be no more than 1 point. Now I'm talking about the geometric horizon. Yes, we see the apparent horizon.
Right.
But with atmosphere or without atmosphere, the location will still remain in the same position.
Yes, the geometric horizon will not change with a fixed camera position from one day to the next. Yes, you are exactly correct. But obviously we can't see the geometric horizon if we have this atmosphere that may play tricks on us. And the key to me about the black swan image is that he took... Excuse me?
Sorry, I just nearly interrupted you. Carry on, sorry.
No. With the black swan image is that the thing about Bo is that he captured other imagery from that exact same location on a different day. Same camera height, same equipment, same beach, same everything. And the horizon is in front of the far platform. And so the interesting thing is when you compare these two images, and hello, Jim Jackson. The interesting thing about these two images is there's clearly a whole lot of distortion in one image and then very little apparent distortion in the other. I'm not saying there's no distortion, but one shows, the steel doing things that steel is not supposed to do. It looks like it's made of silly putty or taffy. And that's the image. There's like, oh, this is the proof. It is this image that shows this the everything all distorted, and this other image, which was literally taken from the same exact spot where, straight lines look straight in the structure of the oil derrick. That's the one that shows the horizon where the horizon is, supposed to be. And so the fact that those two images exist side by side is evidence to me that, yes, conditions can change that can move the horizon. So therefore saying where the horizon is not really a globe killer that people were trying to make it out to be,
But you do agree. I mean, you did just say that we don't see the geometric horizon, right?
Yes, because we have an atmosphere, and the
Because we have atmosphere.
does distort.
The only horizon that we see is the apparent horizon. Yeah.
Yes, and I
that
would
would mean
argue
that
I would argue that apparent horizon is within a half a degree of where it actually is. But go ahead.
Yeah. I mean, we could argue that, but the point is that the horizon that we do see is not the physical geometric one. It's the one that fluctuates, moves back and forth. It can obviously extend over 10 miles and beyond. So if we're not seeing the geometric horizon, then that would indicate that any object disappearing over that horizon is not because of the Earth's curve, because obviously we will never be able to know when things are disappearing bottom first due to the geometric point, because that's something that we never been able to measure to or locate. Yeah. So that's how I understand it.
Right. So the argument, and thank you, Debate Night. So the argument is that, let's say, just for argument's sake, the Earth is flat, and that because light is bending downward, the horizon distance is changing, and that it may obstruct things, bottom up. We have this hump of water which is imaginary because the Earth is flat. Is that kind of what you're saying?
I wouldn't necessarily call it a hump of water.
What appears to be a hump of water, the water is obstructing, meaning that what we see as a horizon is obstructing that far object, oil platform, etc.
I mean, you've seen train tracks where they converge, and it appears to converge.
The vanishing point, right?
Yeah. So, as like with a hallway, as you look down a hallway, the ground will rise up and the ceiling will come down. And the same thing is what we see when we go outside in the real world. The ground appears to rise up. It's just an appearance, not actual, as we've stated.
Yes.
And the sky appears to drop down, giving us that horizon line. Now, obviously, that can change minute by minute, day by day, hour by hour. So for me, unless we're able to locate the actual physical point where things would disappear. So, for example, if I'm a 1 foot observer and a boat leaves from my location, when that boat reaches 1.2 miles, we will never be able to see a physical obstruction. We'll never see the boat physically disappear at the given distance.
Right.
We'll always see it disappear at the apparent horizon, which obviously is immeasurable. We can't actually measure to that horizon. So that's where my argument kind of comes in, is that if you're 6 foot, the horizon's around 3 miles, but we'll never see objects disappear physically, bottom first, at the given location. So that can only tell us one thing, that we are looking at an obstruction that is caused by refraction or light and things of that nature.
Yeah. Well, what would you say? And Debate Night makes a good point, is that the black swan, he says the black swan claims that the size of the Earth changes with the weather. So again, you have those two images side by side. One shows the horizon a lot closer to where quote unquote globers say the horizon should be. And then the famous black swan image with the distorted oil derrick shows the horizon, miles back from where.
Yeah.
So it's like, well, did the shape of the Earth just change? Did the radius of the Earth just change from one day to the next? And
no, because we just agreed that the horizon is apparent, and we're not able to locate So the Earth can't change size because we can't locate the geometric horizon, you see. So
yeah, and it's an absurd question. I mean, nobody is suggesting that the size of the Earth changed from one day to the next. It's a rhetorical question, and the answer is obviously no. So
no, of course not.
Therefore,
But that's the key here. The key here is when things are obstructed, whether it be a mountain, the sun, a building, a boat, anything, a pier, platform, oil rig, anything beyond the horizon is not being blocked by the Earth. That's the key here. Because if it were to be blocked physically, it would be blocked physically at the allotted distance for the observer height. Yeah, so like I say, if you're 1 foot, 4 foot, 6 foot, there's a given geometric distance where things should physically disappear bottom up. You see, and that's something that we don't see in nature.
Yeah, I get that point, but one of the things that I always ask again is like the error. What kind of error are we talking about? So if you had a theodolite, so we're talking about the horizon moving up, the horizon moving down, things moving positions, such as the 2 black swan images. You've probably heard of the Skunk Bay. Do you know the Skunk Bay time-lapse imagery?
Where it's refracting and it's going up and down. Yeah.
Right. So the key about the Skunk Bay imagery is that the camera is, obviously it's bolted down. It's a time-lapse image that takes place, like all day. And so clearly you can see the horizon is physically moving up and down. I mean, when I say physically, it's visually, it's visually moving up and down. You can see further land. The land disappears in the back and then it comes back up into view. And so clearly there's lots of stuff going on. But my question is, what is the error? And it turns out that the error is less than half a degree. In all that distorted imagery, the error is less than half a degree on all of it. And then, which I would argue is a very small error. So,
well, I mean, again, when you say error, there can't be any errors when it comes to the distance, like I said. So you can include all the refraction, you can include all the atmosphere that you need. It doesn't change the physical geometric point of where things should disappear bottom up. So that's why I think the black swan is a very good argument, because it shows that when we see things obstructed, it's never obstructed at the distance given by the globe.
Yeah, because we don't live in a vacuum. That's the key. Is that like the if you use the 8 inches per mile squared, or if you use one of the simpler Earth curve calculators, there's no refraction there. And we all know that light does bend downwards in normal atmospheric conditions.
But you do agree that when we see things disappear, it's not because of the Earth's curve. As you've said, we only see the apparent horizon. So we can only see things being obstructed by this apparent horizon, yeah?
Yeah, but I would argue that the apparent horizon is very close. It's within a half degree to where the real horizon is. But that the error is just because of a little bit of atmospheric refraction. And sometimes the refraction is really bad, and sometimes it's really little, but it's less than half a degree in all cases.
Well, I mean, again, that's based on the model. That's based on the assumptions.
Yeah.
But if we were going by what we observe, obviously, when we look outside, like I said, it's the apparent horizon is causing the obstruction. We've never seen any time the Earth, the physical Earth, causing obstruction that conforms with the calculations of the heliocentric model or the globe, the radius that we're...
I would argue that we do. The Avenger, I'm going to say, I posted the comment on the screen, and he says, I guess this is intended for you. You have to be able to explain all observations on your model. The globe can explain all observations. Can flat Earth do the same? And so what I would say is that you say, well, that doesn't conform to the model, and it's like with less than half a degree of refraction, every observation of stuff on the horizon, boats going over, the sunrise, sunset, etc., everything is explained in the heliocentric globe model, and I would argue to within half a degree, and that half a degree error is only on the horizon.
Well, I mean that varies. You see, I mean when you say half a degree, because the horizon can change at different distances, I mean, unless you could locate the actual geometric horizon and say, well, this is where the geometric horizon is, and this is where the apparent horizon is, which we've never been able to do, which, like I've been saying, we've never been able to locate the geometric horizon. So therefore, what you're calculating is based off the assumption that the Earth is a globe and it's been measured. So what I'm getting at is that when we look at something disappearing and you say, well, that's only half a degree, that is only going by the model and the assumption, that there is actually curvature. But we can see visually that between the observer and the horizon, vast distances, which do not comport. Yeah.
Right. But hopefully you understand that if you're talking about a globe that is 25,000 miles in circumference, and we have a little bit of refraction, I don't know if you can see my finger. If you have a little bit of refraction that is moving, if you have a line of sight and then you move this less than half a degree, well, where it hits the globe may be miles and miles and miles apart. Just a little bit of bend to refraction, you could see miles and miles and miles further.
I mean, I could go with that, but the key here for me is demonstrating that any obstruction is due to a geometric point.
Yeah. So in the interest of just moving the conversation along, we've been talking about geometric and apparent horizons for quite a while.
Okay.
Let's talk about some other topics. And I do want to say thank you to everybody in the chat. And so one thing that Nathan Oakley has always challenged me on is where do I find R? And my answer has always been, and welcome Nathan. My answer has always been, you have to figure out the shape of the Earth before you can measure it, right? Which is why if you take Eratosthenes, I mean, it wasn't with two sticks. There was a well, and then there was a measurement of a shadow. Yes, that works on flat Earth, right? Eratosthenes, with two locations, works on a flat Earth with a local sun. Okay, so my challenge to flat Earthers is that let's not focus in on the size of the planet until you figured out the shape of it. Flat versus globe. And so that's why I say people, to look at the sky, and very few people seem to understand why exactly I'm asking people to look up, because it's and so yeah, Nathan Oakley, just kind of tone it down a little bit. I'm gonna show your comment, but I think the bot is catching you, because I think the word idiot is a trigger for the bot, but if you look up, and then you find that things in the sky are exactly where the globe model predicts them to be.
I mean, I don't have an issue with people wanting to use a model. It's not something that I would adhere to, because as we outlined in the beginning, you have to accept certain conditions, you see. Now, when it comes to Eratosthenes, you have to also make assumptions on distance to the sun. Mm-hmm. You have to make assumptions that the other observer is, deviating from the previous one. And, like I said, these things in the model will give you that information because you're going by a model. But in the practical and physical world, how do we measure the distance to the sun? And things like that. I mean, when obviously observations show us that the rays are converging to a local area.
How do you say the rays are converging?
That's just through observations.
Oh, what kind of observations?
Just like when we go out and we see
crepuscular rays, like when the sun's behind a cloud and we see these sort of the sunbeams. They call them God rays. Is that what you're talking about?
Yeah. So those rays, we see them at angles. We don't see them running parallel, which is what is needed in order for Eratosthenes to be.
So here's a lined piece of paper, but if I hold the lined piece of paper like this, those lines are now converging. Right, those lines are converging like sunbeam rays, like crepuscular rays, but you clearly could see the lines are actually parallel. So when you look up on the sky and you see a bunch of sunbeams, that is something that does happen with parallel lines. I mean, yes, the sun could be right behind those clouds, like the sun could literally be 10 miles away, right? Mm-hmm. So that's one explanation. Unfortunately, if you go 1,000 miles in that direction, they still look up and they still see the sun up in their sky. So
Right.
the sun is not right behind the cloud. Like if the sun were right behind the cloud, yes, you would still get those beautiful God rays,
In the model, in your model, you mean, yeah?
Yeah, no, I mean like in real life. In real life, if you had like a bunch of mist or something or clouds, and then you have a really really bright light source, and you put it right behind the clouds, you'd be able to get these God beams, these beams of light, because the light is right behind the clouds, and it makes these God beams coming out.
Do you have an observation of the sun rays being parallel at any height?
Yes, yes. I mean, they've actually photographed crepuscular rays from airplanes. You can also see anti-crepuscular rays. So there's a video, I don't have it queued up on right hand, but
Okay.
if there's a video where they're looking at crepuscular rays, they're looking at the sunset, and then the camera goes up, and you could see the rays going parallel over their head, and then the camera turns and they look behind them, and you see the lines converging again on the other side.
Walk me through how you would measure the distance to the sun.
Oh, you need to figure out the shape of the Earth before you can figure out the distance to the sun. So in all of my explorations, the distance to the sun is simply very far away.
How was that figured out? How would you determine that?
Well, actually, that's a very good question. For example, if you are on like a plaza, in ancient Roman times they have a plaza. The plaza is perfectly square, and then the sun comes in. You could then trace an angle on the on the flagstones, and then you could run over 100 yards away to the other side of the plaza, trace the angle, and you'll find the angle is exactly the same. There's a bunch of ways of figuring out that the sun is really far away. Now, in our modern day, we have modern communications. You can pick up the phone and you could say, "Hey, Joe," and Joe is 1,000 miles away from you. I'm looking due east and I see the sunrise. And then you could have Joe, and Joe lives 1,000 miles away. Like, let's say Los Angeles and New York City. I think Los Angeles is a bit south of New York City, but Los Angeles and Philly, I don't know what latitude Los Angeles is. So the guy in Los Angeles is looking due east, and he says, "Hey, I see the sun, and the sun is due east of me. Maybe it's so many degrees off the horizon." And then he calls the guy up in Philly, and the Philly's like, "Yeah, the sun's due east of me also," right?
Mm-hmm.
So like that's one way of if two observers 1,000 miles apart
Mm-hmm.
both see the sun in the same general direction. I'm not saying exact direction, but do you see what I'm saying? But there's a lot of ways of telling that the sun is really far.
Yeah, I mean, again, I'm just here to listen to ways that these things are done, I should say.
Yeah,
and that's what I'm hearing is part of the problem, is that we have to make quite a lot of assumptions and assume these things before we can know them. And even then, we're still left with begging of the question here. We're still left with hypothesis stage. Nothing quite practical, demonstrable. In terms of making measurements.
Can I interrupt your thought? Just hold that thought for a moment.
Yeah,
so I do want to say to the folks in the chat, first off, I really really appreciate it, and Nathan Oakley is welcome in the chat. His comments are welcome, and I want everybody to take the spirit of this channel, just like Jim Jackson said. The spirit of this channel is civil discourse. Technically, you guys are all a guest in my house, and in my house, I would like people to talk to each other, and not get heated. So, please debate points, but debate points at a lower temperature. And this is addressed to the folks in the chat. And I do appreciate you guys being here. I really do. And thank you very much, Monkey Sage, for the super chat. So yes. Please continue with what you were saying. I guess you were talking about the model. We were talking about the distance to the sun, and I don't even go there. I just say, the sun's really far. I subscribe to the heliocentric model, which says the sun is about 93 million miles away, but like that's not what that's not the focus. I just say the sun is really
that's
far.
The thing, you see, a lot of these things are just a belief. And if it's just a belief, it's based on faith. And, as flat earthers, we look for a practical element. So at some point, the globe earthers are going to have to show physically that the sun is, outside of the atmosphere, 93 million miles away in space, as you described.
Yeah.
I mean,
well,
speaking of space,
go ahead.
we can move on to other
Yeah.
areas.
Well, no. What I was going to say is the ancients, and I don't want to appeal to the ancients, but they did figure out the Earth was a globe centuries before they figured out any kind of reliable estimate of the distance to the sun. So I don't want to focus in on the distance to the sun because that's not the central part of my argument. But a central part of my argument is looking up in the sky at the sun, moon, and stars. What do you see? And that lines up perfectly with the globe.
With the globe model, Charles.
Yeah, the globe model, the heliocentric model. Right.
Yeah.
Right.
Yeah, okay, that's fine. But again, there's nothing definitive here to suggest that we are on a globe. Like I said, we have a model for both ideas, which obviously, in my mind, is misplaced concreteness, where we just go with the assumption that things are true without actually having demonstrated those things to be true. Now, we kind of spoke about gravity. Do you agree that gravity is not a force?
I don't. I'd rather not have this conversation because it ends up turning into a whirlwind. We only have 15 minutes left to discuss.
Time has flown by. Yes.
Yeah, time has flown by, and I'm happy to have another conversation with you. But the thing about my civil discourse is it's an hour-long chat, and I've had 2, maybe 3 conversations with people. But I do want to cut this one off at the end of an hour.
Okay,
and then,
okay.
And we
so
can,
let's go to the next point. Absolutely.
So yeah. So basically, one of the things about looking up is that you can get a sense of whether the Earth is turning or not. Like that's one of the hugest things, especially if you look at the night sky, the stars. Mm-hmm. You see a celestial equator. You see a north celestial pole. The people in the south see a south celestial pole. You really get a sense that there is a sphere, an imaginary sphere of stars. That surrounds us. I'm not saying it is an actual sphere of stars. I'm just saying it's a virtual, You can kind of build a star map in the shape of a sphere. Okay. And you can see that star map, that imaginary celestial sphere rotating. And that's only possible if the Earth were a globe, because everybody on Earth sees that same celestial sphere, but they see different sides of it. Right. If everybody saw the same celestial sphere, the Earth could be flat with a sphere rotating around it. Like, I don't know if you could see my hand on the screen.
Yeah.
The Earth could be flat, and the celestial sphere could wrap around it. And this is what some of the ancient civilizations did think. If you go way, way back, they mapped the stars, but the stars were like a sphere that wrapped around the flat Earth because it was their local environment.
Right.
But now that we can communicate with people in other areas of the world, and they're looking up and they see a different portion of the celestial sphere, then we kind of know that the Earth can't be flat because they're looking at a different side of the sphere than we are. If that makes sense.
In order for the stars to wrap around, as you're describing, they would need to go over a geometric horizon. As we've established that the horizon is apparent and it fluctuates, and there's no way for the stars to go below the horizon at any point. Okay, so the stars, they move east to west, yes, all around.
Well, they rise in the east. They rise in the east and they set in the west. But if you look due north, you're going to see the stars are moving west to east because they're rotating around the north celestial pole, or you can call it Polaris. Polaris is off by a little bit.
Well, what I've found is because we put a challenge out for globe earthers, if they could show 3 observers, one in Australia, one in South America, and one in South Africa, and they were able to observe this celestial point, this southern point, all at the same time, that would go a long way to demonstrating your model. Now we know now again, I don't adhere to maps or models. But if we take a look at the map, the 2 distances between South America and Australia would be impossible for them to see the same point, the same stars at the same time. That is not so they don't see these stars, but we're talking about at the same time. So obviously they would get on the blower on the phone and say, "Hey, I'm looking at these points," and the other 2 observers say, "Hey, I'm looking at these points as well." they'd be able to live stream it, record it, give us the data, and say, we're all looking at this point at the same time, which obviously wouldn't work on a flat horizontal plane.
Right.
And obviously only could be explained on a globe. So that is another practical demonstration that would go a long way to showing that we are on what they say that we're on. But I've been asking that for many years now. We've never been able to get 3 observers in the south looking at the same set of stars at the same time. So that is a challenge for any globe earther who believes that they're on a globe and there are stars at this point.
Hold on is asking, why does it have to happen at the same time? So the thing is, if the people in South America are looking due south and they look up and they see a south celestial pole during their nighttime, obviously it's going to be daytime. Like somebody's going to have daytime in Australia when it's nighttime in South America. So what you're asking for
not
is
quite,
that it's
not quite, because I have looked. Looked into.
You'd have
there
to
is
do
a wind.
it.
Go on, sorry.
No, you'd have to do it in the South America's winter or Southern Hemisphere's winter. Then I think you might have.
There is a window of opportunity.
The window of opportunity, right?
Yeah, for this observation.
But you definitely could get like 2 out of the 3. But
2 out of the 3. I mean, would you be able to get? Yeah. Would you be able to get someone in South America and Australia to see those southern points at the same time? Obviously, like I say, on a flat horizontal plane.
That would be a good challenge. Are you familiar with the various star trackers and there's Stellarium, there's various simulators that you can use. Stellarium is probably one of the most famous ones. There's free ones that you can have on your phone, and you can put your location anywhere. And the question is, I've never seen anybody say that what they see doesn't match what the simulator says. And Jim Jackson had a really good point. And if he's watching sunrise in Valley Forge and he called a friend in Los Angeles, they're not going to see exactly what he's seeing. So in Los Angeles, it'll still be nighttime, when the sunrise is in Valley Forge, Pennsylvania.
Is he talking about the observation of the southern pole there? Well, the reason why it has to do at the same time is because this would not work on the flat horizontal plane. It would be very difficult for any flat earther to explain how 3 observers in the south are looking at the same point at the same time. Yeah,
and my point, and the thing is that there is a window of opportunity. I don't know of any personal, of any person, but the reason why I was talking about Stellarium is, first off, you could fire up Stellarium and you could put in your location and you could go outside and you could in other words, you could verify that what Stellarium is simulating with just a bunch of math, you see with your own naked eyes in your location. Okay. So then you can kind of play around with Stellarium and you could just put in a different location. So it's like, well, wait a minute, Stellarium is only correct for your location, but maybe it's fake for everybody else. And it's like, I think I've never heard a flat earther say Stellarium is wrong. I went outside and I looked up and it didn't match what Stellarium predicted, right? Well, then just plug in those three locations. You could set the date to be, I guess, what would it be, the June solstice? Right, the June solstice would be when
they have
nighttime is the longest.
There is that window, like I say,
yeah.
Because for sure, if somebody wanted to debunk the flat Earth overnight, that would be another one would be a 24-hour sun in Antarctica, uncut, not a 2-minute time lapse. We're talking real time, real observations. You want
a 24-hour long video?
24-hour long. I mean, again, we've been in this for so long, many years. So I'm sure an extra 24 hours wouldn't go amiss or be a problem for any flat earther to observe and see that. Again, this would be very difficult for flat earthers to explain.
Yeah, well, no, it would be super easy for them to explain. The video's fake, right?
There you go. There you go. Real time. If it was real time.
No, the video's fake. Real time video's fake. I've never been to Antarctica, therefore that video's fake.
Possibly.
I'm teasing, of course, right?
Yeah, but I hear what you're saying, possibly, but it would go a long way to demonstrating that you do have a 24-hour sun in Antarctica, which we've only seen time lapse. Sorry?
The testimonies of the people who live and work there or who have visited there. You
Well, I
know?
did actually speak to someone in Antarctica
Okay.
on one of the platforms, and he said he was down there. And I asked him if he could provide evidence of a 24-hour sun, and we had a conversation. And when I asked him for the full 24 hours, we never spoke again.
Yeah. Yeah,
Yeah.
well, because that would be, I would be put off by that as well. Like, you know, you're asking me, like, what camera even has the capability of recording? Like, not even GoPros, like, you'd have to have like a laptop with like a massive hard drive. You'd have to have a webcam.
Hmm.
You'd have to protect because you're out in the elements, so you'd have to
Hmm.
protect it from the from the weather. So it's like and this is why sometimes in the flat Earth debate people ask the impossible. Like for
Well, I
example,
mean, I think just
Cavendish in a
live
vacuum.
stream. I think just live streaming it is
Well,
not
there's
that.
a bunch of weather stations in Antarctica that have a webcam that's posting data all the time.
Hmm. Hmm.
So, but the thing is that you don't even have to go all the way to Antarctica. You could just talk to people who are in the southern part of South America, and they
Hmm.
say that in like in this part of the year, December, they're getting a lot more daylight than they are getting nighttime. Which is kind of hard to explain on the flat Earth model, but it's super easy to explain. See, one of the things about the globe is that you have what I call remarkable symmetry. So I'm in Philadelphia. Philadelphia is 40 degrees north. I believe you're at 50 degrees north, if I'm not mistaken. You can go 40 degrees south latitude and go ahead 6 months, and they're going to see exactly what I see in terms of the sun motion in the sky, the moon, the stars, everything, the angles, all the motion in the sky is going to be exactly the same 40 degrees south 6 months later than 40
Okay.
degrees north, which is where I am. And this is only possible on a sphere. You can't have any kind of flat model where the further you get away from the North Pole on the flat plane. Hey, we've got 3 minutes left. You know what? We've
Yeah.
got a bunch of topips that I think we can table for next time. I would love for you to get the last word in. So if you could, if you got 3 minutes to riff, but I do want to shut this down in about 3 minutes. So,
No problem. It's been a
Kimo,
pleasure,
yeah.
Charles. Thank you for having me once again. So yeah, I mean, I've got a video on my channel. It's Spurs Chemo, and it just points out how NASA are hiding the alleged ice war. Let's put it that way, because they show us footage of them going around the Earth, and then if you compare it to, again, I'm just saying the flat Earth map, but we don't have one or anything like that. But the map that's been put out there, when they reach key areas on the flat Earth map, mainly in the south, the camera cuts and it kind of hides something. Now, I would say it's hiding an ice wall. Others would say something different. But yeah, this for me is indicating that they're showing us something, but not. It's hidden in plain sight, and people are not questioning why they would cut the cameras at these strategic points on, a so-called flat Earth map. And just to move on to other things, it's just we're about the practicality.
Mm-hmm.
If it can't be measured practically, physically, we're not likely to accept it. If it's not science, okay, with an independent variable, dependent variable, and an experiment to show the claim, then we're not likely to accept it. So like I said, as I started off, we do have models for flat and globe, and it's down to the individual. It's more like a personal opinion, a personal choice of which one you kind of would go with. So yeah, I mean, the people can decide based on faith, or they can decide based on practicality. So yeah,
All right,
that's who I am.
those are very good. Those are very good points, and I think that's a great place to stop. I want to say thank you, very special thank you to my guest Kimo. I will in the show notes. I'm going to put all the links that people have been mentioning. Links also, the link to your channel. I'll put all the links in there. Just give me some time. I want to say thank you so very much for everybody in the chat, and thank you to all the super chats. Very very generous. I really really appreciate it. And just thank you so much for being kind to each other, having a civil
Yeah.
discourse. Kimo,
Spasiba Balshoi.
all
Thank you.
right. Thank you so much. And everybody, have a great rest of your day. Bye-bye.
Bye bye.